within the whole Data4GD project, we have a separate biodiversity file, which is mostly about habitat connectivity, and not really focused on species occurrences, even though we have this element as well in our project. But I would like to tell you a bit about one of the steps of this comprehensive biodiversity pilot, which is actually just the first link that you can see here is pre-processing, and to cover these satellite imagery, OpenStreetMaps, and world database and protected areas. So I've decided to consider a few levels of complexity in this tool. And the first one is quite simple. Just imagine that you are a researcher, you have some strange land use and cover data set, and you probably don't know where it came from. Like on the left side, you have some categories, categorical data, 24 types, for example. But then you realize that you don't have enough features actually for your subsequent analysis. Might be anything, but you don't have enough features like, for example, roads or railways, and we can see them on extra features picture. And then you will use other data sets to actually fetch this data. For example, you can use, I don't know, some local regional databases. They might have these features, might not have them. They might have historical data. They might not have historical data. It can be actually really different depending on your case study. But in Data4Land, we are attempting to actually fetch data from OpenStreetMap because they have some historical data from 2012. It's not much, but it's something for land use land cover dynamics, which is actually important for not only for land use dynamics, but also for habitat connectivity dynamics, sometimes for carbon stocks assessments, different ecological frameworks like reducing emissions or deforestation and so on. And there is some demand from researchers, ecological, environmental consultancies, and so on. That's the first complexity level, and it's quite simple. We are just getting data from OpenStreetMap and burn them into land use land cover. But what if we have actually time series of land use land cover? Because for our case study for Catalonia, we have data from 1987 to 2022. Of course, we cannot use data from OpenStreetMap database because before 2012, because we don't have this data, but we can run some analysis, dynamics analysis on data from 2012. In this case, Data4Land's tool is not really different from the first complexity level, but we need to adapt it to the list of this time series. For example, 3 timestamps like we have here. And just from the first visual assessment, we will see that there is definitely something going on. Just look at this huge stain of burnt areas that was in 2012 in the area of northeastern Catalonia. The third complexity level is about protected areas. Sometimes we might not consider actually, we might look at additional data sources because land use land cover data sets, they do not cover effectiveness of conservation, of nature conservation. That means that if probably, for example, some area is protected, if some area is protected, that will be probably more convenient, more suitable for species to live there, to migrate within these habitats, and it has additional components. In this case, we are using the world database on protected areas with their own API, which is quite simple, but it requires user authentication, credentials, tokens, and so on. So these parts of Data4Land tool is not automatic because you should put token in configuration. But in the result, we can enrich the output dataset with protected areas. In this case, we are using just multiplier of 0.5. That means that protected areas, that species living in protected areas, for example, they how to say, their life is double-fold easier there compared to other areas. That's just a simplification. Of course, it all depends on the user which value they would like to put into this team. And this one will be really tough to explain, but I'll try. There is such indicator as landscape resistance or impedance or friction or cost, and it basically just means the suitability for species to migrate between different habitats. It all depends on land use and cover data sets. For example, red fox, they do not like to move between wetlands, for example. They would like some superforest meadows or something like this. So wetlands are not actually useful for them. From the OpenStreetMap database, we can also extract stressor. It's the second picture. For example, it might be just a road. Then we can calculate distance from the stressors and actually edge effects from the stressor, because roads impacts adjacent habitats as well. Sometimes even hundreds of meters or even more. It depends on the nature of the stressors. For example, this one is motorway in northeastern Catalonia. And then we have multiple stressors, motorways, railways, industrial areas, other built-up areas. And what we would like to do in this case, we need to consider the effects from all of them and choose the maximum value. Yes, to run this tool, of course, land use and cover datasets. Its definition, it's basically just a mapping between each land use and cover dataset and corresponding landscape impedance or resistance value. For example, for marine water, but of course 1000 because it's maximum value, and species, terrestrial species can't pass through in waters. What can be also done in this case for Data4Land, we are looking forward to implement land use land cover change scenarios. And speaking about AI, it might be probably also useful to implement text to SQL learning models for OpenStreetMap, just to transform the user-given inputs. For example, give me all rows in this area to SQL query and automatically get data from OpenStreetMap. We can also calculate cumulative effect of biodiversity stressors. We are calculating just the maximum so far. And also play more with the proposed filters to make them more flexible. But any other suggestions are also welcome. Yeah, so this tool is currently command line tool. We have 4 commands, but it's not going to make sense to focus only on 2 of them. So the first one is actually getting data. Just look here. The last slide is getting data from OpenStreetMap database through awesome API. It's actually really awesome because it's in terms of performance and time. And we are getting some pre-configured data for a study area, which is northeastern Catalonia. Here we can choose between different years. We have 3 timestamps, and we will decide to choose all of them because we would like to take a look at dynamics. And we are retrieving some features, roads, railways, waterways, like here. It all takes seconds for this particular case study, but I would like to say that you should be cautious about that because larger areas are really heavy in terms of performance. Like for the whole Catalonia, it will take 30-40 minutes to extract all of the features. So you should be cautious and also take a look at the pre-configured queries to OpenStreetMap database. Yeah, so it's all extracting some features, and you also get some vineyards because there are a lot of vineyards in Catalonia, especially in the northeastern Catalonia. And there is a lot of pre-processing that you can currently see because it's verbose modes, and that's what all been discussed, that these small pre-processing steps, they might look simple, but actually takes a lot of time, and computing for I don't know, reprojecting data sets, cleaning all data values, clipping them, and so on. It's always takes. Well, actually, you won't see the visual output here, but yes, it took around 2 minutes in something. And the output is the reached land, used land cover data sets for each year. So we could compare the dynamics between from 2012 to 2002 for subsequent computations like edited connectivity. Yeah, I think.